is now.
Have you ever imagined what will happen to planet Earth if a big asteroid comes and hits it? It's not a fantasy. 65 million years back, a big asteroid of the size of about 10 kilometers came and hit the planet Earth. And what was the result? We have the extinction of dinosaurs. So what may happen if a similar size asteroid comes and hits the planet Earth? Of course, the probability of it happening is once in a million. Do you know that on Earth, every day, more than 20,000 meteors comes and hits? But they all get burned up in space about 100 kilometers above the surface of the Earth. And that is what we call as shooting stars. But if a big asteroid comes, they can pass through the atmosphere and come and hit the planet Earth, and we call it as meteorites. But if the size is really large, as it has happened 65 million years back, then what would happen? What would happen to life? What would happen to humanity? Life on planet Earth, we have seen surviving in extreme conditions, whether it is extreme hot, extreme cold, extreme pressure conditions. For example, when you go down into the deep oceans, you still see life. Or even extreme acidic conditions. But what will happen to humanity? Or the form of humans? Have you ever thought that can we transport humanity to other place? Yes, technology is trying to do that, and we have enabling technology which is helping us to do. 23rd of August last year, I hope you all must have seen the Chandrayaan-3 landing, right? In which made India the first country in the world to have the successful landing around the south pole of the moon. And if you see this was the Vikram lander, which actually landed onto the lunar surface. And inside this lander was a small rover, which came out and moved onto the lunar surface. This is just a small model. The jugalbandi between these two, the lander and the rover going around the lander, continued for 1 lunar day. That means about 14 Earth days. But these are all robotic missions. What is going to happen if you want to transport life? There are two big challenges. One is psychological, and the second one is physiological. Psychological means you have to stay in isolation for a longer period of time. How do you communicate? And the physiological means the changes which comes inside the body. Now, humans have overcome this thanks to International Space Station, where humans are now surviving for several weeks to several months. That means humanity can survive in extreme conditions of 0G or low G conditions. And we are able to overcome this. But then the question comes is, how do we go and where do we go? The nearest celestial body for us, the planet Earth, is Moon. How much time it will take to go? It may take about a week or fortnight to go and come back. How much time it takes to communicate? It takes about 2 seconds. In the case of International Space Station, it is just a fraction of seconds because it is just 400 kilometers above the surface of the Earth. But what will happen if we want to go to Mars? The travel time itself is large. You must have heard of India sending a Mars mission to the Mars, which is called Indian Mars Orbiter Mission. It took 10 months for it to reach there. The travel time can be reduced, but still, what about communication? Communication can be as large as few tens of minutes to as small as few minutes. That means if you want to communicate, you have to wait for several tens of minutes. But let us come back to the moon and start thinking about, can we have survival of humans on the moon? What is required for survival of humans on the moon? We need water, we need oxygen, And of course, we need some food for generating energy inside. The Chandrayaan-1 mission of India has already discovered water on the moon. And we all know now that water exists on the moon and is present everywhere, but it is more in the polar regions. In the case of Earth, Earth is tilted by 23.5 degrees. It is something like this. It is not vertical, it is tilted. And this is how the Earth is going around the sun. Moon is almost vertical. And this is how the moon is going around the Earth. So now imagine you have craters in the polar regions of the moon, that is the North Pole and South Pole. They will never see the sunlight. And that's why they are called permanently shadowed regions. That means they will never see the sunlight, they become deep freeze, temperatures can go down to 50 Kelvin. And they become the deep freeze. That means any volatile like water can go and reside there for millions and billions of years. And therefore, they could be the pocket of reservoir of lot of amount of water. That means we need to only harness the water, which is called in situ resource utilization. Once you have water on the moon, I can break it, because water means H2O. So I can break it and make oxygen, which I require for breathing. And the OH which comes out can be used for fuel. So that means I can use moon as a base. Now, can I make water on the moon? Water is there on the moon, we know, but can I make water on the moon? On the moon, we have oxides of all elements present, whether it is silicon oxide, aluminum oxide, magnesium oxide, iron, titanium, you name any element. It is present there, but in oxide form. And these oxides combine together to form minerals. Now, if I break them and take out oxygen from that, and combine with H, it becomes HOH. And if I add one more H, it becomes H2O. That means water. So I can actually produce water, which is like utilizing the resources which is available on the moon to produce water. Now the question comes is, how do we do this whole process? It is called in situ resource utilizations, which is already in place. But then, if humanity has to go there and start staying there, what is the next step? The next step is to use moon as a base for future exploration. That means use moon as a base to go to other planets. Is it easy to do that? Yes, it is easy to do that. Why? Because moon has a gravity which is 1/6 of that of the planet Earth. And that means if I can lift a mass of m on planet Earth, I can lift 6 times higher. In the case of Earth, gravity is the biggest issue. You have to work against gravity to go up in space. But in the case of moon, I can do 6 times higher mass, and therefore it is much easy to go to any planet with higher capability than on planet Earth. But then, if I start staying there, how do I communicate and navigate myself? I hope all of you must have in your pockets this mobile, which is a gadget which has come into our hands just 2 decades back. And we are able to communicate to anybody in the world. Not just communicate, we are able to do voice calls and video calls. And I also use GPS in my mobile to navigate where I have to go. Is it possible on the moon? Yes. GPS is going to come very soon on the moon, which will be helping all the missions and future exploration. And once you have GPS, you know where you are on the moon. And then you know where the resources are on the moon. So it is going to be much easy for humanity to start surviving on the moon once you have both communication and navigation available with us. Now the question comes is, who is going to go? Have you ever thought your grandchildren's or great-grandchildren's going and staying on the moon? And then you go there for holidaying and coming back after a few weeks and saying it was my fantastic visit to the moon, to a certain place, which you will name it, with your own city names on the surface of the moon? Have you ever thought about it? Thank you.